Expert model prediction through feature matching. Here we present our attempt to develop expert models on the BRATS Challenge 23 dataset. In this study, we trained expert models either through training or validating on specific clusters with the goal of having them specialize on specific clusters. We found that the models failed to specialize, but led to a significant improvement in performance after ensembling. We also evaluated the performance of these ensembles on tumor growth segmentation using the same dataset. The study design is as follows. We trained a SegResNet model on the training dataset, which we then used to extract features from the training samples to be used for k-means clustering. With k-means, we cluster into 4 clusters, seen below, saving the cluster centers in the process. By comparing the proximity to the cluster centers, we divide the validation set into 4 clusters as well. With that, we have 3 methods of expert creation used in this study. Method A is where we train the pre-trained baseline model on the training clusters, saving weights by validating on the respective clusters. For example, cluster 1 would be validated on cluster 1 in the validation set, and so on. Method B is starting where we train the untrained baseline model in a similar manner, training on cluster 1, validating on cluster 1 in validation. And method C is where we further train the pre-trained baseline model on the whole training data, but validate on each cluster separately, saving the snapshot of the common model as expert for a given cluster. For example, the baseline model is being trained on the whole data set. You validate on cluster 1, and cluster 1 model say performed best compared to say previous epochs on the same cluster, then the snapshot of that model becomes expert for cluster 1. And at the same time, say if for cluster 3 the model performed best again compared to performances in cluster 3 in previous epochs, again the same model, even though it was saved as expert for cluster 1, is also saved as expert for cluster 3. So in this way, we have experts from 3 different methods. Taking an ensemble of the experts generated in such a manner, we then compare the performance against the baseline on the test set. We found that method A and method C ensembles performed significantly better than baseline, while method B was significantly worse. To evaluate the performance on tumor growth segmentation, we reshuffled the data such that all the subjects with 2 samples were located either in validation or test set. We then evaluated the performance of the baseline model and each of the 2 methods on predicting tumor growth using dice score. The result was method A and method C ensembles led to an improvement in tumor growth prediction as well. For further study, we are planning to test more cases to support the conclusions, including validation with transformer-based model SWIN Unit R. We are also planning validation work on a different dataset and considering combining this method with other performance enhancement techniques. Thank you.